Assalamualaikum and hi everyone. Okay, Galvanic cell part 5. Okay, for Galvanic cell part 5, what you are going to learn, so you are going to use the standard reduction or electrode potential values to calculate the standard cell potential, E0 cell. Before we start, let us recap back what is the meaning by oxidizing agent and reducing agent and its examples in our daily life. What is an oxidizing agent? Oxidizing agent or oxidant is a substance that gains electrons and is reduced in a redox reaction. It is also known as an electron acceptor and has higher possible oxidation number. For example, copper 2 plus ions gains 2 electrons. Therefore, copper 2 plus ion is an oxidizing agent and causes reduction. What is a reducing agent? Reducing agent or reductant is a substance that loses electrons and is oxidized in a redox reaction. It is also known as an electron donor and has lower possible oxidation numbers. For example, magnesium atom loses 2 electrons. Therefore, magnesium atom is a reducing agent and causes oxidation. Combustion reactions are good examples of redox reaction where one molecule gains oxygen where it is oxidized and one molecule gains hydrogen where it is reduced. For example, let's look at what happens when butane gas in your lighter is burned as you push the button and turn the flame to create a spark. Of course, a flame is produced as the butane molecules react with oxygen molecules in air to form carbon dioxide and water. Carbon atoms in butane are oxidized as carbon atoms gains oxygen, while the oxygen is reduced as oxygen gains hydrogen atoms. Therefore, carbon atoms is a reducing agent, whereas oxygen is an oxidizing agent. Having compared many reactions to the standard hydrogen electrode, we can now make a table of reduction potentials for all half reactions. Table 1 lists the standard reduction potential for a number of half-cell reactions at 25 degrees Celsius. By definition, the She has an E0 value of 0.00 watt. Above the She, the standard reduction potentials become more positive. Below the She, the standard reduction potentials become more negative. The E0 values apply to the half-cell reactions as read in the forward direction from left to right. The more positive E0 is, the greater the tendency for the substance to be reduced. Reduction is more favorable. In the cell, the E0 reduction of copper is more positive than E0 reduction of zinc. Hence, reduction occurs at copper electrodes. Therefore, copper becomes the cathode. However, changing the stoichiometric coefficients of a half-cell reaction does not change the value of E0 because electrode potentials are intensive properties. This means that the value of E0 is unaffected by the size of the electrodes or the amount of solution present. However, the sign of E0 changes when the reaction is reversed. Let us consider the following example. First, identify the anode and the cathode of the cell. Since the E0 reduction of silver is more positive than E0 reduction of magnesium, reduction is more favorable at the silver electrode. Hence, silver becomes the cathode, whereas magnesium becomes the anode. There are two methods that we can use to calculate the standard cell potential. The first method is by using the formula of E0 cell is equals to E0 cathode minus E0 anode, where E0 cathode
and anode are denoted as the standard reduction potential of the electrode. Then you can substitute the value of cathode and anode. Therefore, the standard cell potential is positive 3.17 volts. The second method that we can use to determine the standard cell potential is by using E0 cell equals to E0 reduction plus E0 oxidation. Since we have already reversed the half cell equation at anode, therefore, the sign of E0 reduction of magnesium is also changed from negative to positive. Therefore, the standard cell potential is positive 3.17 volts. Let us consider the second example. First, you have to identify the anode and the cathode of the cell. Based on the cell notation, cobalt is the anode since it is written on the left side of the cell notation. Therefore, silver is the cathode. Same as in the previous calculation, there are two methods that we can use to calculate the standard cell potential. The first method is by using the formula of E0 cell is equals to E0 cathode minus E0 anode. Since E0 cathode and E0 anode are denoted as the standard reduction potential, you can directly substitute all the values. Therefore, the standard cell potential is positive 1.08 watts. The second method that you can use to calculate the standard cell potential is by using the formula of E0 cell is equals to E0 reduction plus E0 oxidation. Since the half cell equation at the anode is reversed, the sign of E0 reduction of cobalt also changed from negative to positive. Therefore, the standard cell potential is positive 1.08 watts.